And we're back with another PicoCTF challenge, this time WPA'ing out, a forensics challenge. Description: I thought that my password was super secret, but it turned out that the passwords passed over the air can be cracked, especially if I used the same wireless network password as the one in the RockU credential dump. Use this PCAP file and the RockU word list. The flag should be entered in the PicoCTF format, and then as hints, we have find the IEEE, which is the Electrical Engineer Association, 802.11 wireless protocol used in the wireless traffic packet capture. It's easier with Wireshark, the jaws of the network, and then Aircrack-ng can make a PCAP file catch big air and crack a password. All right, so let's do what they've asked, and let's open this up in Wireshark. Don't worry about that error. I've had that since I did a fresh install of Wireshark. Doesn't seem to be bothering anything. Since we have a brand new PCAP, the first thing I like to do is I like to look at statistics. We can see we've got about 1 megabyte of capture, 23,000 packets, and a little bit less than 2 minutes worth of time that we were capturing. Going into our other statistics, we look at our conversations, and we don't see any, which is really weird. And then finally, I look at the protocol hierarchy. And here you can see we have a lot of IEEE 802.11 wireless LAN traffic. We've got some authentication action that happens, and then we've got data. Let's take a look at the data quickly, and let's see what we have. So we have this source, which I'll just call BE, and 1A, and they seem to be talking back and forth, 1A to BE, then back. And if we look at the data, it's kind of gibberish. It's just text with no discernible meaning. So it's probably encrypted. Let's take a look at the other sources that we have in here, the other traffic, and we have the authentication. So let's apply this, and let's take a quick look. So we see we have these messages, and they seem to come in groups of 4, message 1 through 4, and these are the establishment of a key. So let's take a step back and let's look at the original problem. So we had air cracked in caps, and here we talk about Aircrack-ng. Aircrack-ng is a way that we can capture wireless traffic using its set of tools. So as a quick example, this guy runs you through the process of bringing up your wireless interface in promiscuous mode, meaning it will capture any traffic, not just traffic that's directed to you. And then he uses the AirDump-ng to actually create the PCAP. So that's what we're looking at here, is we have a PCAP, and it came from the observation of some client, like this wireless notebook, trying to access an access point, so a router, and they have to do an initial exchange of information to establish a session key. Why do they do that? Why not just use the password? Well, because we are, as human beings, terrible, absolutely terrible at establishing good, secure passwords. As an analogy, I want to just consider the FBI's top 10 most wanted. So these guys, they're all trying to avoid being caught. And how do you do that? Well, you've got a huge world, so you want to go some random place where people won't expect to find you. Makes sense, right? Well, what if I told you all these guys just decided they were going to camp out right here in Kansas on this driveway? It'd be pretty stupid, right? You've got all this space, and if the FBI just knew, hey, these guys, they always go to this driveway. Every FBI top 10 most wanted guy, they've decided this is the best place to be screw being in Iceland, Greenland, anywhere else, we'll go there. Well, that's kind of what human beings do with passwords. So let me make it a little more concrete. Let's say you had 3 letters with which to make a password. People like meaning. People like something like dog or cat, something that's not just random characters. So they tend to go with dictionary words. Maybe they throw on a 1 or an exclamation point or something like that, but they keep it very simple. So we can see here, Scrabble defines about 1,000 different words that are legitimate dictionary words. But how many total words could be formed from 3 letters? Well, we can quickly find that out. Let's only consider lowercase letters. So there are 26 letters for each of the 3 positions. So 26 times 26 times 26. So you could make 17,000 words, roughly. Now let's consider if you were to use uppercase, lowercase, special characters, and numbers. So maybe we say there are 72 possibilities now. Now you've got about, I call it 400,000 possibilities, just with 3 characters, right? But some of those are not going to be fun for a human being to remember. So we don't use that space. Speaking of space, so once you start talking about 72 characters and you have to have, say, a password requirement where they say you have to have at least 10 characters, well, what does that work out to? Well, that would be 72 to the 10, which is a truly massive number. This is an almost meaninglessly large number. So unfortunately, though, like I said, human beings are lazy, and rather than use this huge, massive space, they're going to pick an area that's the size of like the head of a pin in this picture, and all those passwords will be there. So what we're going to do is the 4-way handshake that we talked about that happens here, because human beings pick such weak passwords. We have the 4-way handshake captured, and what this is doing is, again, the computer and the security guys would love if we had a password like this that was just crazy gibberish nonsense, some special characters in there. That would be great. That would be so hard to find. That would be the equivalent of picking anywhere in this broad space. But again, human beings don't do that. So instead, what's going to happen is, to keep it friendly for humans, we'll exchange, so we know both the client and the server here, your router, you know what the password is. You won't exchange that, but you'll do some complicated math and pass back and forth values, and you'll establish a session key. And that session key will be very strong. So strong, we can't really attack it meaningfully. But if we have these handshakes, we know that the weak password that a human being picked went into creating this handshake. So that's what we're going to attack here. And the way we're going to do that is with a dictionary attack. And this is hinted at in the description. So they talk about the RockU word list, which was a credential dump. So what we're going to do is we're going to use RockU, which I'll show you right now in the terminal. I'll use a find to find where RockU is, and I'll just pipe my errors to dev null. All right, so I have this RockU credential list, which was a huge password dump. So this gives a good example of how human beings like to pick their passwords. Let's look at the top 20 entries in this. And we can see it's things like 1234, 123456, password, I love you. It's a bunch of bad passwords. We're going to use a tool called Hashcat, and Hashcat takes very specific input. So to find out what that input was, it won't just take a PCAP. I just literally Googled how to convert a PCAP into Hashcat format. And I found this nice tool, which will lets you specify an output and a PCAP. And we don't need the word list. We won't be using that. So I'm going to do the conversion right now. And then we are going to try to crack this. And I need to change my desktop, clear the screen so you guys can see. And we are going to say handshakes is what we'll call this output. And we're going to pass it our PCAP, which was WPA'ing out. And it does have some complaints in here, but I've already run this and I know that it's good. This is OK output here. And we'll verify just by going onto the desktop and taking a look at it. So we created handshakes. Let's open that up. And this is going to look weird if you've never done any password cracking. But this is specifying the WPA standard, and then it's giving a whole bunch of information that the password cracker will need in order to attack this password. We can verify by taking a look in our instructions. Hashcat has many different things it can attack, and you pass that with -m. So -m says whether this is like an Ethereum wallet or this is network traffic or anything else. It can attack many things here. As a matter of fact, we'll take a look at Hashcat right now, just to give you guys a sense of all the different things that it can attack. So these are the different not methods, but I don't know, targets, for example. Let's find some stuff you guys would recognize. So blockchain wallets, Electrum wallets. Skype has a particular way that it encodes its passwords, or hashes, I should say, hashes. BitLocker, you get the idea. PDFs can also be secured. So if we were wondering, is this properly formatted, we could Google for example hashes, and we could find this nice table here, and we could look for 22,000, which was the method that we saw was in use. And yeah, these look roughly the same. So let's go ahead and let's attempt the password cracking. We'll specify the method. We will specify handshakes, and then our word list. All right. And perfect. It was very easy to crack. You can see that we initialized, we started using this dictionary here, and then we got a hit here, and we have two things. We've got Gone Surfing and Mickey Mouse. Why do we have two things? What's going on? Well, if we go back to Wireshark, and if we take a look at our traffic, what we can see is the SSID is Gone Surfing. So that would be the name of the router. So if you were to look, unfortunately I'm in a VM so you can't see, but if you were to look at available wireless networks, this is what you'd see. So it's called Gone Surfing, and the password happens to be Mickey Mouse, which makes the name of this challenge make a whole lot more sense. WPA'ing out, wiping out, surfs up. And you see it here with, you can catch big air here. So kind of, I don't know, surfing skater terminology. So now that we have this, we'd probably need to be able to look at this encrypted data in order to proceed. So what we're going to do is we're going to provide this information. Actually, before I do that, I want to remind you of the protocol hierarchy. So we see this authentication traffic and data and not much else because it's opaque. It's all encrypted. So now we're going to try to unencrypt it. We'll go into protocols, and I'm going to type in IEEE. Kind of annoying, there's another 802.11 up there, but it is what it is. And you see we have enabled decryption here, but we need decryption keys. And so we will place this in. And it's not a WEP key. WEP is a weaker standard. It's WPA, and it's a password. Let's go ahead and say OK, and let's re-examine our protocol hierarchy. And nothing changed. Why did nothing change? Well, I did this to show you guys a very common pitfall you'll encounter when working with different tools. So we saw this Hashcat tool. This dumped this in this format of SSID and then password. Unfortunately, that's not the expectation of Wireshark. Wireshark expects it to go the other way. How did I find this out? Well, by screwing up and then thinking maybe it could go the other way. And that's a lot of this job and this field, unfortunately. It'd be nice if everything worked, but it doesn't. All right, beautiful. So now we can actually inspect into things, and we can see some UDP, some TCP. This is really good. So let's do what we normally do, which is let's take a look at our different streams. We will say tcp.stream equals 0, and we'll follow the stream just to try to make sense of it. And we'll take a look at the streams that we have. We've got some XML being pulled, some kind of requests that doesn't make a lot of sense to me. All right, nothing there. So let's take a look at UDP. We'll start at stream 0, and we'll again follow. And if this is all new to you, I have a series of Wireshark tutorials which go through this. So we see this, which I'll link above. We see this wave machine. I don't really know what that is, but let's just remember that. Some gibberish, wave machine again. I'm going to go through this rather quickly. This is the process I would go through, but unfortunately it doesn't turn anything up. But again, I want to show you, we see Pico, very tantalizing, but no dice. Okay, we are not going to find anything here. And this is the part where I complain about the construction of this problem. So the first part was fine and great and dandy, but you can't find anywhere something like PicoCTF in the unencrypted traffic. We can do some quick checks too for something like UDP contains Pico. Sorry, I can't type. And you can see we get close. We get tantalizingly close, but you don't find anything. And logically, you think, I have an encrypted PCAP. I'm going to find the password there. I spent about 20-25 minutes on this, and then I just started trying these different, the password, the SSID, and other things. And I found that that's what they were looking for. So when we put in PicoCTF, Mickey Mouse, and submit the flag, it works. So kind of terrible in my mind, because that means you wouldn't have had to go through the effort of figuring out how to open this up in Wireshark and look at the actual unencrypted traffic. And moreover, you kind of had to guess instead of, being explicitly told. It would be really nice if it was just in here so you knew. But there you have it. Thanks for watching the video. I'm going to keep making these, and you can help in a number of ways. First, liking and subscribing encourages me to continue doing this type of content. It sounds like BS, but seeing people say I helped them does make my day. Second, in the comments or on a subreddit I made, you can suggest future content. Every 2 weeks, I'll look at what the most requested challenge is and make a video on it. Finally, I have a Patreon if you'd like to financially support this. Thanks, and have a good one.